So today we are starting off transformations, and the first one we're going to talk about is translations. So we will be using vectors. Vector is a quantity that has both magnitude and direction. And it's represented by this notation. So if I'm looking at that picture, I have P and Q. It's going to be kind of like an arrow, but only on the top. So I'm representing from P to Q right here, and it's that notation right there. Okay, so it consists of an initial point, which is where I start. And then a terminal point, which is where I end. Okay, so a component form of a vector combines horizontal and vertical translations. And then I need to write my component form of PQ. So what I'm going to do is it's going 5 units to the right and 3 units up. The way I write this is I have this little arrow looking thing, and then I'm going to have 5, 3. So this is telling me 5 right and 3 up. So these examples here want me to name the vector and write its component form. So the arrow is going towards the N. So I write the letter M first, and then the N with the vector symbol above. And then to write it in component form, I need to figure out how many it's going right and then down. So how many squares is it going right? 4. And how many is it going down? 2. So I'm going to represent that with a -2 since it's going down. I always write left or right first, and then up or down goes next. And I represent down by the negative. Okay. So on number 2, which letter do I want to write first, P or Q? P, and then Q. Then I write the symbol above it. How many am I going right this time? And how many am I going up? 1. Since both of those are positive, I write them positively. So number 3 says the component form of GH is 4, 2. That's telling me how I'm going to change it. I'm going to go right 4 and then up 2. And I need to move this triangle. So the first thing I'm going to do is I want to plot these points. I have 3, negative 1, 1, 1, and 3, 5. And then I want to connect these to make a triangle. It's also very important that I label the letters as I draw them. So then I want to move A. I'm going to go right 4 squares and then up 2. And then when I write A, I'm going to write a little apostrophe next to it because this is telling me it's not my original A, it's a new A. And I'm going to go ahead and do the same thing for C. I'm going to go right 4, up 2, and then my C gets a little apostrophe next to it too. And then same thing for B, right 4, up 2, and again it gets a little apostrophe. Then I just need to connect my points to make the triangle. So we're going to talk about different transformations. Figures in a plane can be translated. That just means I slide it around. They can be reflected. So, like when you look in the mirror, it flips around. Or they can be rotated to produce new figures. Okay. So the operation that maps or moves the pre-image onto the image is called a transformation. So the figure with the A over here is going to be my first figure. This is called my pre-image. And the one with the little apostrophe is my second one. This is called my image. So if the pre-image is A, and then the image is, this is read as A prime, it goes as A maps to A prime. Translation is a transformation that maps all of the points of a figure the same number of units in the same direction. Okay, so if triangle ABC is equal to triangle A prime, B prime, C prime, then all sides are congruent. And that means if I had something like AB, it would be congruent to A prime, B prime. And I would do that for all the sides. So I'd have AC is congruent to A prime, C prime, and BC is congruent to B prime, C prime. All of my angles are congruent. So angle A is going to be congruent to angle A prime. Angle B is going to be congruent to angle B prime. And angle C is going to be congruent to angle C prime. So that just means the angles that match up the same letters are the same. It doesn't mean that A is congruent to B. Okay, and then the area and perimeter stay the same. Okay, so then we have translations in the coordinate plane. On the front side, we talked about it where we could write the notation in vector form. We can also write it in what is going to be called coordinate notation. So what it's going to have is it's going to have a point x, y, then an arrow, and then I'm going to say x plus some a, comma, y plus some b, and that's basically telling me how much to move x and y. So if it's positive for x, I go right. If it's negative, I go left. If it's positive for b, for b, I go up, and if it's negative, I go down. So if I take a look at this picture, it is going to the right 4. So in the notation I have x plus 4, and then it's going down 2. That is represented as y minus 2. So number 4 wants me to describe the translation using coordinate notation. So how many squares am I going up? And how many am I going right? 5. So I start off, all of these will start the same. I do x comma y, and then my arrow. Which of those two numbers is being added to x, 2 or 5? No, remember x is always left and right. Yeah, the 5. And then that means the 2 has to be added to the y. Okay, number 5 wants me to sketch a triangle with these vertices of A is -1, -3. B is 1, -1. And C is -1, 0. So I label those as I plot them, and then I want to connect them because it tells me it's a triangle. Okay. Then it says to sketch the image of the triangle after the translation xy goes to x minus 3, y plus 4. So that means I'm going to go left 3, up 4. So all of these points, I'm going to go left 3, 1, 2, 3. Then I'm going to go up 4, 1, 2, 3, 4. And put my new point, and then I make sure I mark it with the image notation. I'm going to do the same thing for B, so I'm going to go left 3, 1, 2, 3, up 4, 1, 2, 3, 4, and then give it the apostrophe for my notation. Same thing for C. I go left 3, up 4, 1, 2, 3, 4. And then mark it with my notation. And then I just want to connect my points. Okay, so a translation is a type of rigid motion. A rigid motion is a transformation that preserves the shape and size. So this means they just stay the same. So I'm not going to turn a triangle into like a rectangle, and it's not going to get any bigger or smaller. It's going to stay exactly the same. So if I went and measured my triangle up here, it should measure the same as my blue triangle down there. Another name for rigid motion is an isometry. Means the same thing, keeps the same shape and size. And then I can have a composition of transformations. That just means I am doing more than one transformation. So I think you guys did this when you were doing the Desmos practice, where you could like flip it and then rotate it. You could do more than one, and it'll still keep the same size. Then on the back side, just some examples. So this one wants me to graph RS with the endpoints of -8, 5. So that one is a little bit off my graph. And S is -6, 8. Okay, so for this I'm going to connect my 2 points. So this first one wants me to go right 5, down 2. So each of those points I'm going to go over 5. 1, 2, 3, 4, 5, and then down 2. 1, 2. So this one's going to get R with one of the apostrophes. Same thing for S. I'm going to go right 5. 1, 2, 3, 4, 5, and then down 2. 1, 2. Again, I mark it with an apostrophe. And I want to connect these two. But it wants me to do a second translation. So this one is going left 4, down 2. So each of those points, I'm going to go left 4. 1, 2, 3, 4, and then down 2. When I write out my R this time, I'm going to have a double apostrophe because that means I've moved it twice. Okay, then I'm going to do the same thing for the S. I'm going to go left 4, 1, 2, 3, 4, and then down 2. And again, I think it's the double apostrophe. So I'm going to go ahead and just connect my points. Okay, so this one wants me to translate this figure 3 left and 4 down and then give the coordinates of the image. So I'm going to plot these points. A is at -2, 5. B is at 2, 5. C is at 2, -1. And D is -2, -1. So this one is a rectangle. Then it wants me to go 3 left and 4 down. So I'm going to go 1, 2, 3, 1, 2, 3, 4. I'm going to go ahead and do that for all 4 of these points. So I'm going to go 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 1, 2, 3, 4. Then I'm going to go ahead and connect my points again. So where is my new A at? What's that coordinate point right here? Negative 5, 1. And then this new B, negative 1, 1. My new C, yep, negative 1, negative 5. And my new D, My next one wants me to describe how it is moving between the 2 triangles. So I want to see how many I'm going right and down. So how many squares did I go right from A to A prime? I went 7 right, and then how many down did I go? I went 5. Yep. Yep. So I went 7 to the right, and 5 down. Then it wants me to write the same thing using the ordered pairs. So I'm going to do x comma y, and then that arrow. And it's going to be x plus 7, because I went 7 to the right, and then y minus 5, because I went 5 down. Okay. These next ones want me to draw the image after the translation. The translation is given up top. So first I'm going to go, this one's telling me to go right 3, down 2. So each of these points I'm going to go to the right, 3, 1, 2, 3, and then down 2. And I want to remember to keep writing my notation. You have to wait for one. Okay, the next one, I am going to go left 3, up 4. So each of those points, I'm going to go to the left 3. 1, 2, 3, and then up 4. 1, 2, 3, 4. And then I write each of my points with the apostrophe. 1, 2, 3, 2, 3, 4. Okay, then my last one wants to see under the translation xy goes to x plus 3, y plus 2. The 0.25 will become 5.7. It wants me to decide if that's true or false. I'm going to plug in for x and y. So, I am going to have 2 plus 3, and then comma, 5 plus 2. What's 2 plus 3? And 5 plus 2? 7. Is that the point I wanted it to turn into? Yes, so this one is true.